Before we start this video, a large thank you to Lily, Bibbles, Arcadia, Jojo, Brian, Jason, Erica, Jay Rida, and Vladislav for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner for their immense support to the channel this month on Patreon. I greatly appreciate it, my friend, and I hope you enjoy this video. Hello everybody, and today we're going to conclude mostly our lock-on system. We'll come back and add a couple things to it in the future when we make some more changes, but right now all the functionality is definitely going to be there. So let's start by opening up our player controls, and what we're going to do is make two inputs, one for the left and then one for the right selection while locked on. And you can just call these seek left lock on target and seek right lock on target, or lock left, lock right, whatever makes the most sense to you. I'm going to make them the right stick slash left and then right stick slash right respectively. So this again is a button. So every time we tilt the stick left or right, if you're using a controller like me, it's going to trigger this action here. So once that's done, we're going to go back into the player input manager and set up the inputs as we normally would. So let's open that up now after this saves and jump in there. And I'm just going to add these inputs under the lock-on input header here. So I'm going to duplicate the lock-on input, and I'm just probably going to call it lock-on underscore left or right. I could call it select left or right lock on target, but I feel that's a bit long. So I'm just going to call it lock on underscore left input. And then I'll say lock on underscore right input. And then down here on enable, like we do with every other input, let's just set it up down here as we've done before. So we can just copy the first one here for lock on. And instead of player actions dot lock on, we're going to say select right lock on target, or select left lock on target, and then just make that change its bool respective to what it is. So left is going to enable the lock on left input, and seek right lock on target is going to enable the lock on right input. Okay, so it appears I have a spelling error here. Oh, I forgot the underscore. Once that's done, we can actually make a separate little function for this. You could put it in handle lock on input if you want, but just to keep it clean, I'm going to give it its own, because this is only going to trigger when we're already locked on and selecting the left or right lock on target or searching for an additional target. So I'm going to make a private void, call it handle lock on switch target input. And we're going to do two main things in here. First, we're going to check for the lock on input itself. So if lock on underscore left input, we immediately set that to false, so it's not running more than once. And then down here, we're going to say if player network manager is locked on dot value, then we want to run some logic. So if we're already locked on and we've attempted to switch our lock on targets, we want to say player camera dot instance handle locating lock on targets to give us a new set of targets in respect to where we're at right now. And then I'm going to say if player camera dot instance dot left lock on target does not equal null, and this is not a variable yet, but we're going to go make it right after this. So if we do have a left lock on target, we're going to say player combat manager set target player camera instance left lock on target. So it works very similar to how locating the closest target works. So let's go and make the functionality now to locate left and right lock on target. So I'm going to copy the nearest lock on target, and this is in the player camera script. I'm going to paste it. Gonna call it left lock on target, and then copy and paste that again and call this right lock on target. All right, let's save that, and I'm just gonna move this variable above here so the targets are together and the speeds are together. So let's go down to the handle locating lock on targets function. And now we're going to utilize our shortest distance left and right that we made last video. So we're gonna say right down here, where we're iterating through the available targets, we're gonna say if player network manager is already locked on. So if we are already locked on, let's actually locate some left and right targets for our character to actually access. So basically this is going to handle searching for not our nearest target now, but our nearest left and right target in respect to the person we're locked onto right now, or the direction we're facing, I should say, while we're locked on. So it's going to be vector3 relative enemy position, that's our first variable, is equal to player.transform.inverse transform point. You can see transform position from world space to local space. That's all this does. And then we're going to pass inside of this our available targets k.transform.position. So this just gets us a point from world space and brings it into local space. So that's why I called it relative enemy position. And then I'm going to make two variables just using var here. Distance from left target. We're going to say that equals relative enemy position.x, and distance from right target, and that also equals relative enemy position.x. Now you probably remember that conversation we had a long time ago, or in a previous video, where I said basically if it's in a negative value on the x, it's to the left, and if it's in a positive value on the x, then it's to the right. So we're going to use that now by saying if relative enemy position.x is less than or equal to 0.00, so that would make it left, and distance from left target is greater than shortest distance from left target, because remember it's a negative value because it's negative math f dot infinity. And lastly, we need to check if this target is not our current target. So if available targets k does not equal player.playerCombatManager.current target. And now that I'm writing this out, we're going to simplify this and make it look a bit cleaner. We're just going to take this target check and basically move it before and just say continue. So let's copy this, delete it from here, and then right above this relative check, we're just going to say if the target is equal to the current target, continue on to the next target in this for loop. Okay, so if the relative position is less than 0 on x, we know it's left, and if the distance from the target is greater than the shortest distance of the target from left, we know it's closer. So we're going to say shortest distance of left target equals distance from left target, left lock on target equals available targets k. And if one comes along that's closer, it's going to update that and change the left lock on target and the shortest distance. Else, if the relative enemy position.x is greater or equal to 0, then we know it's to the right, and the distance from right target is less than the shortest distance, because this is a positive value now, then we're just going to do the same thing, but we're going to say shortest distance of right target equals distance from right target, right lock on target equals available targets k. So it might be a bit confusing because the left is in the negative and the right is in the positive, so it looks a little odd, but this is how it's going to work. We're going to check for the left side for targets there, and then we're going to check the relative position x for the right side if it's greater than 0. So again, if it's less than 0, it's got to be left. If it's greater than 0, it's got to be right. That's it. Okay, cool. Now we can save that, and that should work, but we should come down here on our clear lock-on targets now. We should also clear our left lock-on target by saying left lock-on target equals null, and then we should do the same to our right lock-on target. And now we need to actually call this whole function and copy and paste the left lock on input and do the same thing, but change the words left to right, so it will handle locating you a right target if you move the right stick to the right. All right, that looks good. Make sure you don't accidentally leave one as left, and that should be working as intended. Let's go over here now to handle all inputs, and let's actually call this. But before we test it, we need to do something else that's very important. We need to make sure we're forcing the rotation of our character towards our target. That is very important also. So let's save that. Let's go over here now to the player locomotion manager, and where we have handle rotate or handle rotation, let's go down here, handle rotation. Here we go. So let's make an if statement, and we're going to say if, first let's make sure we're not dead. So we're going to say if player.isDead.value return. We don't want to allow rotation while the character is dead. That could cause some funny looking things to happen. Let's also go below here and say if player.player.networkmanager.isLockedOn.value. Open up some curly bracers, else do the normal rotation we've always been doing. Copy and paste that and put it in here. So what do we do for locked on? Well, this one's really easy. We just got to face our lock on target, but there is an exception to the rule. The exception to the rule is if we are sprinting, because in Elden Ring and Dark Souls, if you're sprinting, you don't rotate towards the target, you just kind of rotate towards the direction you're going to run. Or if you're rolling, because we don't have omnidirectional rolling yet, so we'll set that up later actually, but we want to make it so when we roll, we're also going to roll in the direction our joystick is. Otherwise, we'll have the roll forced towards our lock-on target, and we don't want that. That won't be a problem with omnidirectional rolling in the future, but we'll get to that when we get there. So let's say vector3 target direction equals vector3.0. Target direction equals player camera instance.cameraObject.transform dot forward times vertical movement. It's the same thing really as our regular rotation essentially. Then we're going to say target rotation plus equals player instance. It's a little bit different though. Dot camera object dot transform dot right times horizontal movement. You can see here now we're going to come down also and say target direction dot normalize and target direction dot y is equal to 0. Okay, so then we're going to say if target direction is equal to vector 3.0, target direction is equal to transform.forward. This actually might be just like our regular movement, but I'm going to put it here anyway, just so we have a separator in case you want to tweak the logic in the future. Quaternion target rotation is equal to quaternion look rotation target direction, and then we're going to say quaternion dot final rotation. I'm going to call this, and we're going to make that a quaternion dot slurp between the current rotation of the player model and our new target rotation, just so we're not rotating suddenly and abruptly. So we'll say transform.rotation and target rotation by our rotation speed times time.delta time. And then lastly, we set our actual rotation of this player object to the final rotation. Okay, so that is, I misnamed that, final rotation that should be. So that's what we're going to do for sprinting, and this will basically allow you to run around freely and not rotate towards your target while still being locked on. Otherwise, if you're not sprinting, we're going to be strafing, and we need to make our character forcibly look at the target at all times. So first we're going to check and make sure the target's not null. If it is, we're going to return, otherwise you'll get some weird behavior. And then we're going to say vector 3. And again, this will be the rotation direction or the target direction. You can call it whatever you want. Same thing up here. I'll just use target direction to keep the naming conventions the same. We're going to not initialize that instantly. We're going to say right below the target direction is going to be equal to player combat manager current target transform position minus our transform position. Alternatively, you could say player transform position because it's the same thing. But transform position is in the position of this game object because this script is attached to the same game object as the player manager. Then we're going to say target direction y is equal to 0, and then we're going to normalize it as we did before. And then down here, we're going to say quaternion target rotation is equal to, and we want to do is just look at this target. So it's very simple. We just say quaternion.look rotation, and we pass our target's direction. And all this does is rotate, or the rotation is basically in the direction that we just made. So the direction is the player current target transform position minus the transform position, and then the rotation is just looking in that direction. So then likewise we say, like above here, we say final rotation is equal to a quaternion dot slurp between our current transform position and our target rotation. And then we pass it by the rotation speed by times time.delta time. And also we want to make sure we're saying transform.rotation equals the final rotation, otherwise it again will be a bit stuttery. So let's save that. And let's go into the player input manager. And here, this is again on the handle player movement input. We want to make it now so we're actually setting up our strafing animations by saying if player.playerNetworkManager.isLockedOn.value, otherwise do something else. So if we're not locked on, I'm just going to use not locked on, we'll rotate, or rather move normally without our horizontal movement. Otherwise, we are going to want to use our horizontal movement. So I'm going to pass our horizontal input and our vertical input instead of the move amount there. So this will go to our blend tree now and allow us to access all of the movement on the blend tree. And also, we want to say if we're not locked on or if we are sprinting, we don't want to use the horizontal and vertical input because you're not strafing while you're sprinting. You're going to break the strafe and sprint in the direction that you're facing. All right, let's save that again. I'm going to go over now and copy this actually because I think we use this in one more place and it's for our net code. So let's find out where we use this. Yes, right here. So if we are the owner, do this. Otherwise, we do this. So just pass the same thing. Basically, if the sprinting flag is true, we're just going to update the move amount only. And if we're locked on, we're going to pass the horizontal movement and the vertical movement. So it's the same thing over here. All right, let's save that. And I'm going to move my comment up here so it's clear. If not locked on, pass on move amount. If locked on, pass on horizontal and vertical movement. So let's go back to attempting to find a new target here on the handle lock on input if our target dies, because this is something we want to do. Now we're going to use a coroutine because we don't want to snap to the target instantly if your target dies. Otherwise, if you're mid-attack, that could be really weird. It'll be very jarring and not comfortable at all. So we're going to make a coroutine called wait then find new target. We're going to say while the player is performing action, or if you're attacking, which we don't have yet, so we can come back and add that later, because sometimes you can attack without performing an action. It's in very special cases. So if the player is performing action while they are doing it, yield return null means do nothing. Afterwards, clear lock-on targets, and then handle locating lock-on targets. And then if our nearest target does not equal null, we're going to set that as our current lock-on target by saying player.playerCombatManager.setTarget. And what does this do? It waits for you to finish the action that you're doing. And then if your current target is dead, that's when we're going to use this. We're going to set a new target to the nearest target. Then we're going to say player.playerNetworkManager.isLockedOn.value is equal to true. All right, so where are we going to call this? And right below here, we also need to say yield return null. So we're going to call this every time we're switching a target, or every time our target has been killed. So let's go down here now and make a private coroutine on the player input manager. Call this lock-on coroutine. And the reason why we're storing this locally is because we never want to run this twice. We never want it to overlap on accident. Like say if you get a target, they die, and then their target dies, or some weird stuff happens. You never want the coroutine running and overlapping itself. So we're going to say if lock-on coroutine does not equal null, stop coroutine, lock-on coroutine. And then we're going to say lock-on coroutine equals start coroutine, lock-on coroutine. This makes it so this is never running more than once at the same time on this script. So then we're going to start the coroutine player_camera.instance wait then find new target. So again, this assures us that this coroutine does not run more than once at a time, and then it's just going to wait for your action to stop and then give you a new target if your current one is dead. So if I go in the game here and test this, I'm going to click on this dummy. If I toggle is dead, you'll see I'll snap to the next target. So this one's dead. If I untick it now and go back. Now if I attack and then click is dead, it waits for me to finish my attack and then snaps to the next target. There you go. So now it won't be jarringly snapping you if you're mid-attack, causing you to redirect your attack if you can rotate. So we have another problem here now. You can see that I can kind of slide across the floor, and that's because we're not snapping our movement values, but we're going to get to that in a little bit. Before we do that though, we have another thing to do on the player camera. So let's go down here below handle locating lock-on targets, and let's make a void called set lock camera height. So we're going to change the height of the camera while we are locked on, and we're going to change it back while we are not locked on. So I'm going to make a coroutine here, a private coroutine. This is on the player camera script. I'm going to call this camera lock on height coroutine. Again, because we never want to run this more than once at a time. So I'm going to say if the camera lock on height coroutine does not equal null, stop that coroutine. And then we're going to say after that, camera lock on height coroutine equals start coroutine, and let's make a new coroutine for this. So we're just going to call the coroutine, or I'm going to call it, you can call it whatever you want, set camera height. And this is going to run every single time our lock on flag changes. So if we acquire a target, is a better way to put it actually. Even if our target is null, that would mean that we don't have a target, so it's going to change the height back to the regular height. So we're going to call this after, or in the same place we call set target. Now, we're going to do some things in here depending on if we have a target or not. So first, let's make a serializable field float unlocked camera height. I'm going to say 1.65 maybe. I think that's what I tested with, and it felt pretty good. This will depend on your models and the feel you're going for, but my lock on height I'm going to set, so serializable field float locked camera height, I'm going to say 2.0. And again, feel free to tweak this as you see fit. This is just what I'm using. It feels good in the project. So let's make some variables first here. We're going to say float duration is equal to 1. Float timer is equal to 0. So this is how long it's going to take basically for it to finish this coroutine. I'm going to say vector3 velocity is equal to vector3.0. Vector3 new locked position is equal to, and we're going to change the height, remember I said in the other video, of the camera pivot object. So I'm going to say new, let's make it really clear. new locked camera height is equal to a new vector 3, and we're using the camera pivot dot transform dot local position x. Then we're going to say lock on camera height, and we're good to go. And then we're going to do the same thing for the new unlocked camera height. And we're going to again reference the camera pivot transform dot local position x and then the unlocked camera height. So we're referencing the camera pivot transform because we're changing the y value of that to change the height. I gave a brief demonstration in the previous video where I just did it manually to show what it would look like, but now we're going to do it with code. So now we have our values. We're going to say while the timer here is less than the duration, we're going to say timer is equal or plus equal to time.delta time. So it's going to go up. It's just going to count to 1. And while we're doing this, we want to say if player does not equal null. That's important, especially in netcode, in case somehow this object breaks, it'll just cause an error. Then if we have a player object in here, we want to run our logic as normally. So we'll say if player dot player combat manager dot current target does not equal null, we do one thing, otherwise we do another. So what do we do if we have the current target? Well, we're going to gently move the camera's height to the new height, and we're going to force its rotation to 0, 0, 0. So we're going to say camera pivot transform dot local position equals vector 3 smooth damp between the camera pivot transform dot local position and the new locked camera height. And now we should give this its own speed, but for now I'm just going to put ref velocity, and I'm going to use the speed we already have, which is lock on follow speed, but this is temporary. We're going to give it its own speed in a moment. Let's just get the rest of this logic ironed out first. So this handles the position. Now let's also guide the rotation back to a 0, 0, 0. So we're going to say camera pivot dot transform dot local rotation equals quaternion slurp camera pivot dot transform dot local rotation, and then we're going to pass a new quaternion dot Euler 0, 0, 0. And again, this one we can actually keep the lock on target follow speed for because this is a rotation, and this is how fast the camera is going to rotate towards the lock on target. So that's fine. Now down here, what we want to do, if we don't have a target and somehow we're calling this function without a target, which is correct, then we want to guide the camera back to its unlocked height. So we're going to say camera pivot transform dot local position is equal to vector 3 dot smooth damp camera pivot transform dot local position and the new unlocked camera height. Again, reference velocity, and we're going to say we can put in lock on target follow speed for now, but we're going to change that in a second. So we're going to give that its own variable. Why is this giving me grief? Oh, not local rotation, local position. That's my bad. Okay, let's save this now. And before we exit this this code routine, I want to do a couple of things. First, yield return null inside the while loop. That's important. Otherwise, logic won't run. It'll act very weird. So this is right below the if statement. And then right when the while loop is complete, just to make sure that there's no weird discrepancies, let's just snap the camera's pivot, transform, and rotation to its proper values, depending on if you're locked on or not. Now, this shouldn't happen, but this is basically a catch or a failsafe. So if the camera, for some reason, doesn't go back to the intended height during this lock-on or this camera height while loop, it's going to manually set it at the end of the while loop. And you'll know this is happening because it'll appear to snap. And if it does snap, then you know something is going wrong. But this is just going to catch it so the camera is not caught in some weird in-between. So if their target does not equal null, set the transform position to the new locked camera height and the rotation to 0, 0, 0. And if the target is null, then we're not locked on. So set the position to the new unlocked camera height. And that's it. So then at the end, we just say yield return null. And that should be working as intended. I guess we'll see momentarily when I test it. So I'm going to minimize that now, and we're going to save that. And now we need to call the set lock camera height. Now, where are we going to do that? Well, if we go to the character combat manager, you'll know that we have a set target, but we can override that because it's virtual on the player combat manager because our player is the one with the camera. So if you go here, you can see it just sets the target, and if the target's null, the current target is equal null. So this is perfect. So let's go back over here now to the player combat manager, and we're going to say if we are the owner of this player object, meaning if this is the local player doing this, then we're going to call upon the player camera instance.set camera height. So set lock camera height, and we're good to go. Now if our target's null, it's unlocked, it'll set us back normal. If it's not null, it'll set us to the lock type. So let's make a speed now for that camera to move. And the lower the speed, the faster it's going to be. So serializable field float set camera height speed. I'm going to say 1 right away. It's definitely going to be too high, but I'm just going to put it as 1. We'll try it in the scene and test it live to see how it feels. Now replace where you move the camera's height with this new variable. You can keep the camera's rotation as lock on target follow speed. All right, I'm going to save that now, go into the game, and I found what works for me is 0.05. I'll show you. So I'll just click onto the enemy here now, and you can see it. There we go. It snaps up. I can run around, and it snaps down. It looks very nice. So I'm happy with that speed. You can see it's just above my head, so I can see them clearly. If I go full screen here, just to give you a better idea, you can see that, yeah, that looks nice. So we still have the problem, though. The problem being that if I basically walk very slowly, we'll start moonwalking. Rolling also looks a bit weird. It's snapping for some reason. That's weird. Okay. I'm going to add a flag on the character locomotion manager for is rolling because we're going to need it in a future video anyway for a couple of things. But what we're going to do is we're also going to make it so that if we are rolling, we don't rotate towards the target. As I said before, this way you're not forcing your rotation to basically roll you towards the person you're locked onto. You want to be able to roll away from them. So let's go into attempt to perform dodge. We're going to say player.playerLocomotionManager.isRolling is equal to true. And we need to reset that when we're done rolling. So we do that by going to the empty state on the animator, opening up reset action flag. And then we say character.characterLocomotionManager.isRolling is equal to false. I apparently don't have a character locomotion manager variable on my character manager, so I'm going to go make that. So yeah, basically in the future, we're going to have omnidirectional rolling, which means we're going to be able to roll in 8 directions while we're locked on, like back left, back right, backwards, forward, forward left, forward right. But for now, we're not going to have that for a while. So we don't want our rotation while we're locked on to always force us to roll into our lock on target. So let's call character locomotion manager in a way, set that up. I don't need to tell you guys how to do that now. You're familiar with that. Basically, this will make it so we can roll away from our target while we're locked on, which is what we want. And we'll update this in the future when we have omnidirectional rolling. So let's go back now to the handle rotation, and we're going to say if we're sprinting or if we're rolling, do not force us to rotate towards our lock-on target. And let's save that. Oh, I see the problem. I'm not passing my final rotation also here. So target transform.rotation should be final rotation while you're locked on, not the rotation before. Now I should smoothly, yeah. So my rotation now smoothly rotates me towards the target. If I break it, it doesn't just snap me. Okay, so that is working as intended. We can roll now and lock into our target, but you can see we got this moonwalk thing happening here. So let's address that. So what do we do here? This one is very straightforward, actually. And we're basically, remember I told you a long time ago, you can snap your movement input or snap your animator values. That is exactly what we're going to do. So I'm going to open up my character animator manager. I'm going to go down here to the update animator parameters. I'm just going to paste this in here and go through with you. I'm not going to type it all out because it's very simple. So I'm going to paste this code here, and we're actually going to change, before I paste, I'm going to rename horizontal to snapped horizontal, and then vertical to snapped vertical amount. So we're going to pass the snapped horizontal and the snapped vertical to the animator now. And then I'm going to paste in a little bit of some if statements here, and I'm going to go down through it with you and show you. So all we're doing is if the horizontal movement that we pass is greater than 0 and less than 0.5, we always snap it to 0.5. Likewise, if the horizontal movement, and we can get rid of this, we can just say snapped horizontal, snap vertical. Likewise, if the horizontal movement is greater than 0.5 and less than 1, it's always 1. If the horizontal movement is less than 0 and greater than minus 0.5, then it's minus 0.5. And if it's less than 0.5 and greater than minus 1, it's always minus 1. Otherwise, it's 0. So again, we're snapping it to minus 1, minus 0.5, 0, 0.5, or 1. And then we do the exact same thing here with the vertical. And then you pass your snapped values. And that's all there is to it. Now, if I go back into the game, I lock on here now, and I slightly move the stick, you can see I still get that nice clean walking animation because our speed is always a walking speed or a running speed. So our animations should always be a walking animation or a running animation. And I can sprint around, I can roll, and I can sprint while I'm locked on, and everything is working as intended. So there you go, guys. You have a fully functioning lock-on system. You can switch between some targets, and that's going to make combat a lot more engaging. So we're going to add another attack, the heavy attack action now. And then after that, we're actually going to make a very basic AI in the project, and then we're going to get into some combat. This was definitely a bit of a longer one, but I really wanted to finish it up because I was very excited to get it all out there. So if you guys learned something new in this video, I would kindly ask that you like and comment. It genuinely helps out the series so much. And as always, thank you very much for being here with me again this weekend. I hope you all have a lovely weekend, and I will see you next week.